Hello, everyone. Welcome to JetBrains Connect, topics and talk from across the landscape of technology. Today on JetBrains Connect, subject matter experts are everywhere, serving accountants, medical researchers, financial experts, systems engineers. They are frequently the advisors of software we write. They tell software developers what are the business rules of code. Should they be participants in development using domain-specific languages? I'm your host, Paul Everitt. Today, I'm joined by Václav Pech, JetBrains Developer Advocate for MPS. Welcome, Václav.
Hello. Thank you for inviting me. I'm happy to be here discussing these topics.
This is going to be fun with both of our guests because they know each other. Also joining us today, Markus Völter, expert in the areas of language engineering. Language engineering, that sounds great. Domain-specific languages and model-driven software development, and speaker, podcaster, and organizer on this very topic. Welcome, Markus.
Thank you very much for having me. Looking forward to the discussion.
Guests go first on JetBrains Connect. Markus, you've written in this field, spoken in this field, consulted in this field, all for years, maybe I should say decades. Give us a little of your personal and programming background.
Right. First of all, I should emphasize that I also actually wrote some code in this field. I didn't just speak and talk and advise. I actually did some work as well. So I started programming, I guess, when I was 12 years old, like many of us. I made some money programming while I was in school. And then for some reason, I don't really completely remember, I studied technical physics. I don't know why. But then I also did programming while I was studying, made money, on the side while I did that. And since then, I finished in 99. I was mostly self-employed. I did enterprise web applications earlier, but then also did embedded stuff. And then over the last 15 years, I specialized in all things modeling, code generation, language definition. I started with UML and then moved over to graphical textual languages. And now, last 10 years, I mostly worked with MPS, building these kinds of subject matter-oriented DSLs you mentioned.
Great. Thanks, Markus. We're fortunate to have your experience with us today, but also, as we might touch on later, some of the next steps in DSL advocacy. Václav, you've also been in this field, speaking a lot, doing a whole bunch of stuff, helping shape our MPS product as kind of an exemplar, I guess, of this topic. Tell us a little bit about yourself.
No, sure. Actually, I joined JetBrains quite some time ago. It's almost 18 years when I joined JetBrains. And over time, I worked on several different projects, mostly as a developer and also as a developer advocate. And then in 2009, I joined the JetBrains MPS project because it was a project that actually was far beyond my comfort zone at that time. Because, I used to be a server-side Java developer, so that was my domain. And MPS is a totally different beast. It's a rich client Java application. It's a tool that allows you to create languages. So I had to learn a lot of new things, a lot of new theory. So it was really a challenge, and it still is. To apply and to learn and apply all the theory that's behind languages and stuff like that. So, I frequently meet challenges, and that's what I like about
that. Just out of curiosity, how long have the two of you known each other?
All right. I know. Markus, do you?
No, go ahead. If you have something concrete in your mind.
Actually, it was back in 2000. Well, now I'm not sure, 7 or 8, when I was, doing developer advocacy for IntelliJ IDEA and Team City. And I was visiting a conference in Munich. And you were there, and you were already enthusiastic about MPS, and you knew about MPS more than I did back then.
Okay, I probably don't. I mean, we certainly got in touch early on when I and kind of the people in Stuttgart started using MPS. I'm sure that's certainly when we also met in that context then.
Sure. Yeah. But this was really by accident, right? We met at a conference.
All right. So thanks, Václav. And as a reminder for everybody, this topic is going to take some thinking. We'll tell the story and get into the core issue. But what really matters, of course, is what you think. Give us some comments down below about today's topic. We're talking about domain-specific languages, or DSLs, and model-driven software. For this episode, we'll use DSL as kind of a shorthand for the entire field. But what we're really talking about is tooling for subject matter experts. Markus, help us get oriented with a brief history tour of this field.
Right. So a domain-specific language is a language that is optimized, specialized for a particular purpose. That's the domain, right? And so it omits all the language features that you don't need in that domain. For example, it might not have for loops or monads, right? I guess most languages don't need monads. Sorry. It also adds additional first-class concepts that are relevant in that domain. And then the idea is that when you write code, it's easier because you don't have to deal with the stuff that would just add complexity that we don't need in the DSL, and it has direct abstractions for lots of the stuff that's relevant in the domain. And so therefore, programs become shorter, they become easier to analyze because they're semantically richer relative to that domain, and therefore productivity is increased. And historically, these DSLs have been built for various technical purposes, right? Starting from database queries, HTML, CSS, SQL, all of these things we've all seen before. What is a relatively newer idea is to build these languages so that non-programmers can use them. People who know a lot about their particular subject matter, about their particular domain, who contribute to software, as you said in the introduction, but who are not software engineers. So how can we build languages that these people can use, they can understand, they can be productive with, without making them programmers? That's the challenge.
So, Václav, that's the background on the field, and maybe you'll have some comments on that. And Markus, as he's explained it to me, one of the things that really jumps out to me is we're taking their words, their concepts, their entities, and making them almost like first-class language constructs. You're a developer advocate, which means part of your job is listening to the market, what people value, et cetera. We're zooming in on subject matter experts. Can you help us understand this group and their needs?
All right. Sure. Yeah, I can. These people are experts in their particular domains. So they are, everywhere. You can find them in any domain. You can find them, in any field like medicine, construction, tax, accounting. So everywhere people understand their domain. They are experts in their domain, and now they are in a situation where they actually want to build some software that works for that particular domain. And well, that's task for developers because these folks don't write code. That's not their profession. So they hire programmers to do that, and they somehow have to communicate their needs, to them. So that is the whole purpose of domain-specific languages. Give them, the means, the tooling to communicate to the developers in an unambiguous way, so that the description of their needs, of the requirements, is formalized. So, there's a lot of differences between how the domain experts think about the problem that they're trying to solve and how developers do that. There's one difference, very obvious and very visible, is the difference in notations. Right? We programmers, when we write software, we use textual notation. So we write code, and code typically is textual, organized into blocks, slightly indented. So it's a structured textual sort of description. While out in the domains, there are many different notations there. So there's notations, like symbolic. Look at math, right? Mathematical symbols. This is something that's been here for centuries. Yet when we write code in Java, we can't use these symbols, right? Because they are not, like keywords in any programming language. So that's sort of a shame on us. then, these domain experts, they also like tabular notations, diagrams, or text that uses positioning on like fixed positioning on a screen, sort of like a form. And that is the notation that are used to from their domain. So if you ask domain experts to describe their domain to programmers, or with domain-specific languages to actually describe it to the system formally, they still want to use these notations because that's what they've grown up with. That's what they are used to. That's what's the most suitable notation for the domain that's developed over a long period of time. Also, the domain experts, sort of unlike we developers, they don't mind being constrained in how they express their thoughts. So we programmers tend to use sort of free form text. They don't mind constrained language and constrained flow or workflow through which they enter the information. So yeah, the difference is they are different people.
It's interesting that you started with notation, because some, real programmers might say, well, it's just syntax. Who cares? Well, the point is non-programmers care. It's the UX, right? It's the UX of the language. It's how they interact with the abstractions that are relevant in the domain. And so, well, both from a kind of marketing/convincing perspective, but also substantially, the notation is important. If you look into law, legal text, or any other domain informal description, you find tables everywhere for data, but also for complex decision making. Why can't we have them in code, right? So this is a very important point. Just wanted to re-emphasize.
Markus, could you follow up on, you've talked about subject matter experts, but this other genre, I'll say gurus, that there's kind of like two hats maybe that they wear.
Yeah. So there are fundamental, let's try to structure this whole space a little bit, right? So there is the end users. End users get some kind of software. Let's say they get some kind of web application where they can enter a bunch of financial data, and then the web application generates a tax declaration, right? So end users, So then the question is, how does the whole bunch of tax rules, and there are many, as people always joke, Germany's tax law is more complicated than the rest of the world's tax law composed. So I'm not sure it's true, but good joke. So how do all these rules get from the law, from the description in some fat, thick binders? How does that get into the software? Well, that's where the subject matter experts come into play. So we give them a tool with which they can concisely express these rules and test them so that they have a direct path, as Václav said, from brain through DSL to software. Now, the question is, where does this language come from that they use? Who builds the DSL? Who builds the tool, right? And on the one hand side, these are software people. These are software language engineers, people who know how to use MPS, for example, or Xtext to build languages. But how do they know which abstractions to put into the language to make it suitable for these subject matter experts, right? Programmers don't know. So that's where the guru comes in. The guru is an especially experienced subject matter expert, or a small group, right? We joked earlier about this guy called Herman in a previous project who would retire in 2 years, right? So it was important to basically suck out Herman's brain and put it into the DSL. So these are, as I call them sometimes, gurus. They're really experienced domain experts who can think not just in terms of specific rules that go into domain, but also in generalizations, how the domain works in general, because that's what needs to go into the language. And so we need these people together with software language engineers to craft the language itself, which subject matter experts then use.
You're making me think of, instead of DSL, it's BSL, brain-sucking language, but maybe that won't catch on in the market.
Now, the word sucking in any product description is probably rather negatively connotated, but the brain thing is good. And seriously, I mean, the challenge is, how do you get the mental model that experts have in their mind, how do you make that executable? That's what software is.
When both of you were explaining this to me, it reminded me of my days as a content management consultant. And in the example scenario you just gave, if I was writing a system for lawyers, by the end of the project, I'd be an expert in law, because they would have to go to the whiteboard, offload everything to me. And that's not the way that this should be structured. They should be a participant in the software development process, creating actionable artifacts, not whiteboard drawings. Is that right?
Correct.
Right.
All right.
That's
And I think, Václav, you're going to talk about this a little bit later in the discussion and the examples. Is that right?
That's my plan. Right.
All right, great. All right, so thanks both of you for giving us, for DSLs, who it's for, what do they value, which is really the key of this episode. Now that we have the backstory on DSLs, let's get to the core issue. Subject matter experts, or SMEs, highly trained, highly valuable to their fields, and there are a lot more of them than there are of us in software. They are frequently the advisors of software development, sort of like the Herman that Markus just gave us the explanation of. Could they be direct participants in software development using domain-specific languages? If so, what would that look like? Markus, you first. Make the case for letting the SMEs drive the car.
You know, the funny thing is, if we talk about it this way, it's totally obvious. How do you not allow these people who have the experience to directly contribute? Also, if you will, language development, programming language development has always been about finding better abstractions to be more expressive, to be able to express software in a more compact way. But we've always kind of slewed this to computer sciencey things, right? We started with assembly, and then we had functions, and eventually we'd end up with monads. So it became more and more expressive. We built languages that are more and more composable, but in some sense, we moved them further and further away from anything concrete that is like close to any, actual real domain. So I think we should use these highly powerful languages to build stuff that subject matter experts can then use to express what they care about. And the challenge is, how do we get them to want to do this? The language cannot have curly braces because then it looks like programming. They don't want to be programmers. They tell me that all the time. We have to give them the ability to test their stuff. They have to take responsibility for this. They can no longer say, well, I thought it to me, I meant it this way, but then the developer understood it wrong and now the code is broken. No longer possible. It's now their responsibility. So there's lots of cultural changes. There are also tooling challenges. How do you build tools that are like friendly for these people? You don't want 5 million buttons and 20 refactoring menus. So there's lots of UX issues. But fundamentally, in my opinion, it is totally obvious to keep the subject matter separate from all the programming low-level stuff.
Václav, before commenting on what Markus just said, and then getting to your point, I'm thinking of a cartoon where, on the left side, you have all these SMEs saying, important law thing, and on the right, you have the programmer hearing, monad. All roads will ultimately lead to a monad.
Yes.
Václav, do you have anything you want to add to what Markus was just saying?
Well, I think Markus is totally right. And it looks obvious, to us because we've been living in this world, right? And we've been seeing the benefits of this approach in reality. But, but I believe it is difficult to imagine the benefits if you haven't seen it yet. If you haven't seen it before, if it's new to you, then it might look like, you might not see the benefits. So really, the use cases, the success stories is what actually should be heard, and that's what probably can convince people, can show them, that there is this option.
Or you might not believe the success. We have cases where productivity actually increases by a factor of 10. Not in all domains, not in all projects. It was something that is kind of particularly well suited. But if you tell people we accelerated by a factor of 10, they'll chalk it off as stupid marketing. They just won't believe it.
Right.
It's funny.
And something like that, if it winds up being true, it could only be true by like a real paradigm shift in the way the system was constructed. Václav, you and the MPS team, by the way, the M in MPS does not stand for monad, right?
No, it does.
Okay, all right. You and the MPS team at JetBrains spend your time exactly on this to make tools that folks like Markus can use to then build tools that put the SMEs in charge. Nothing specific really about MPS, but this class of software, I think you refer to it as language workbenches. What makes it unique about actually getting that 10x and bringing the SMEs into the process?
All right. Yeah. Perhaps I'll start with a small example, right? So that people who've never seen this before, they can build some concrete picture in their heads. It typically helps me when I'm trying to get the message across. So maybe it will work in a podcast as well. Imagine the the system that is supposed to answer phone for an organization, right? You call in and it gives you the options: press 1 for invoices, press 2 for whatever, speaking to the operator and things like that. Now, this is a tool that is typically used by people in the marketing department because they know how to structure the menu, they know what they want to promote. So, this is something that they can define. However, if you look at the systems that are out there available to the systems you connect to your to the phone line to answer the phone calls, these systems are configured in a highly technical way. You have to configure it with a file that is really sort of highly technical thing. So something marketing people typically will not be willing to learn and maintain. So you have the problem of the business domain is way different from the implementation domain, and you have to bridge it. So one way to bridge it is you create a modeling tool for the marketing people, where they can specify the menus. They can define the menu and submenu, give them the number 1 and 2 and 3 and what should be sort of set into that particular place in the menu. And ideally they can not only just type it, but they have all the bells and whistles of an editing tool. So you've got all the the options like code completion. You've got error checking. So if you by some mistake omit a number, right, you say 1 invoices, 2 something else, and then 4 something else, and 5 something else, you forget 3. Now you would like to have some sort of error telling you, or warning telling you, hey, you omitted number 3. So yeah, things like that. You might also be willing to have tests, so that the marketing people, they can write tests. I mean, tests is nothing specific to programming, right? It's a natural approach that if you do something, you would like to test that it is correct. And in this example, the test can look like just like a sequence of button presses. So a test can say, if I press 1 1 1 2, I want to be in the direct call to the CEO option, right? So you want to be able to write tests like that and run them, and they will sort of tell you whether your expectation that you get to certain entry in the menu is correct or not. And then it is a task of some code generation that will take this high level sort of thing and put it into the real implementation code. So this would be a modeling tool. Now, what is the role of a language workbench? Well, you can create these modeling tools from scratch, or you can use a language workbench to have them created much more easily and faster. So that is the goal for language workbenches. You can think of them as meta modeling tools that allow you to basically create modeling languages and tools fairly easily.
You can almost think of them as meta programming systems, right? Which is, I guess, where the name comes from. But another kind of way of looking at this is that developing languages and their IDEs is, if you will, just another domain. So MPS is basically a set of DSLs where the domain for which they are built is the domain of language definition. Right? It's one of these nice meta circular things that computer scientists like. But the point is that, as Václav said, if you want to do something very specific, something very specialized, language definition, it's probably not a good idea to open your C IDE and start.
All right.
You probably want to start with a bunch of languages and abstractions that are specifically tailored for that kind of problem. And that's what MPS is.
And just to be clear, Václav, this thing you're describing isn't some mythical example. You gave a talk, I think, in 2017 where you described this IVR IDE project, and 2 interns with no familiarity whatsoever tackled this. How did they do?
Yeah, all right. Yeah, that was actually their assignment for their internship, and they started with 0 knowledge of languages and language engineering and the tool that they'll be using. And well, when I think it was in 2 months, less than 2 months, they had the system, done. So they learned everything, and they created a modeling tool that is usable and that really, generates runnable code.
And let me describe this back in the way it would have been without this class of software. And Markus, you kind of give me the interpretation. Tell me if I've got it right. I'm a consultant, and I'm going to build your IVR system for you. You encode everything on the whiteboard or a Google Doc and then walk away. I, as a programmer, have to figure out your IVR system and then deliver it to you. Maybe I've got some forms or whatever, but you're like out of the picture at that point, right?
Well, I mean, you sound a little bit waterfall-y, right? You give a spec and then you go away, and then after some time a developer throws something over the fence and you catch it.
But even if it was agile, my role is to advise, not participate.
Exactly. Yeah, but I wanted to emphasize, because sometimes the whole modeling and DSL story is put a little bit in contradiction to agile, so I'm very sensitive whenever it sounds like that. So of course the idea is that even if you don't use DSLs, you would basically team up, right? The software people and the domain people, and kind of work together. But it would still be in this way. The domain person would do something informal, sketches, diagrams, a little bit of description. And then you as the developer, you would kind of think about it, formalize it, hopefully find some inconsistencies, and then code it up. And the idea is to change that, to keep the software person completely out of the loop here after they have built languages and generators and execution platforms and all the other illities, right, they want to care about. But then for every particular instance, for every stupid tax rule, right, you don't have to care about as a software engineer. It's the domain people do that themselves. They might run into a problem with the generator because it has a bug. Then you fix it as a software person, right? There is another benefit, which I just briefly like to mention. What is a legacy system, Paul? How would you define legacy system?
Something that has been online for more than 10 seconds.
Okay, that's this kind of joking, cynical description, which of course is true. It's also like the code I wrote 10 minutes ago, right?
Right.
A bit more seriously, legacy systems are obviously systems that have been running for a while, but the problem with them is that often legacy usually means you want to replace it with something newer, which basically means you want to run the same functionality in a new technical language, environment, framework, blah, blah, blah. So what you have to do is you have to re-extract that subject matter from that running system, from that old code, because requirements documents, they're long gone and they're outdated. So now you have to kind of unscramble the scrambled egg and extract the egg white and the egg yolk, so you can take the yolk to, mix it with new white in a new technology. And that's extremely painful. So you should rather keep the subject matter stuff completely separate forever and treat the final software as a disposable artifact. So also from an architecture perspective, which software people might care more about than the subject matter happiness, right? It's a really good idea.
Yeah, and I guess I'll add to your analogy, the scrambled egg retired. You can't even go find the original egg that got scrambled.
You talk about eggheads.
Okay, so I think we're good on explaining. Part of a key point to this that both of you were making is we actually want to bring software development principles and machinery like refactorings and debugging into like the business rules part, rather than just put it on a whiteboard and I'll have to figure it out during this agile stuff.
Yeah, exactly. In fact, the models like the voice menu system or the tax law, it's stored in version control, right? You have it in Git, just like the other code. So really, you apply the same principles to these high-level models. So instead of having whiteboard, you have a whole Git history of how the model evolves over time.
Okay, let's go ahead and wrap up this background by just saying that it certainly feels like DSLs and language workbenches are really changing the footing between the programming side and the subject matter experts. Let's have an open discussion on some of the points. Let's start with something really specific. Taxes, very complicated field, constantly changing. lots of rules, and thus a huge professional class of business experts that we've been talking about. I think you can both talk quite a bit about applying these ideas to this domain and some other domains as well. Markus, you go first.
Yeah, it's also a great motivator for software people because it's really, really boring to learn all these, It's seriously, I mean, it is very satisfying if you as a software person can focus on this meta stuff, on analyzing the domain, understanding the abstractions, and then encoding them in a language, right? And then the details can be filled in by the actual subject matter experts who take pride in understanding all the stuff we don't really care about. So, we are working with a German service provider. They develop software which tax advisors then use. Company name is called Datev. And so they have various departments, and two of them, one does salary calculations, like salary slips. They have been doing the MPS DSL stuff for a while. And now, well, also for a while now, there's the second department about creating tax declarations, the thing you file at the end, or in May, I think it's in the US, right? There's this like tax day somewhere. So the software that you can use, or that a tax advisor can use, and so 10,000 data fields, hundreds of validation rules, hundreds of subject matter experts who will use this stuff, 30, 40 different subfields, kinds of tax, executed in finally in Java code in the cloud. And we are building a DSL and also already using that DSL where these subject matter experts can express the calculation rules, the data validation, but also the logical structure of UIs, right? And how to create certain reports and forms. So it's a very kind of, the complete subject matter workflow will be done with DSLs.
And let me guess, whatever is the rate at which people master this, the rate at which it changes is +1.
The rate at which it changes is +1?
Meaning the tax laws change constantly.
Oh, yeah, sure, absolutely. I mean, absolutely. Every year, I think I heard about 10 or 20% of that logic changes in some way. And so there is also this requirement that they have to be able to reproduce tax declarations for 10 years. They have to do a lot of versioning, and it's a really, I mean, it's funny how the domain, if you look at the specifics, like the actual tax rules, it's crazy and boring for people like me. But from an engineering perspective, from building the language, finding the right abstractions and all of that, it's quite interesting, actually.
Václav, I think you have familiarity with this domain, but could you also mention some of the other domains that you know of which have kind of successfully applied this language engineering idea?
Yeah, of course. Otherwise, it would look like that, this
it's only for taxes.
Approach is only useful for taxes. Right?
Yes.
So there's numerous examples, in many different domains. So perhaps I'll mention two. One of them is, an insurance company. They in the insurance business, they've got experts on insurance, which there's a department of those, and they create various rules that describe the business. And historically they've done it in you can use any tool, but they were using Microsoft Word, at least this particular client. In Microsoft Word they wrote the rules for the business. And if you look at that, what they write, it's actually a function with some textual description, and it has some sort of parameters to accept values from other rules or from the system, and then there is some computation, some calculation in there. And the workflow was very fragile back then, before applying these domain-specific languages things, because they had to send these documents to an outsourcing company for manual coding into C, and then that code was actually then made part of the system and compiled and run and tested. And obviously you see the fragility, right? If something changes in either, it has to change in the document, or something is discovered in the code when you run it. Then you have to find where you have to match the code and the document and somehow, sort of reiterate, and it takes forever to reiterate. So now with a language workbench, now they've got a tool that allows them to write code that is very similar to what they used to from Word. So it looks like a Word document.
Actually, we made the syntax really look like Word with bold and lines and stuff. Seriously, I mean, it looks like a Word document, which is absolutely useful in this case.
For adoption purposes, that's brilliant.
Absolutely, yeah.
Right. So that's for adoption, but you get benefits. You get code completion, for example.
You
get underlining. It tells you, here wrong here. You're using a parameter that is actually not sort of available.
It's tooling, right?
Right.
Yeah. And it's tooling, and you didn't have to write it because the workbench gave it to you.
And you press a button, and you've got your C code. There's no need to manually do something. So that sort of Word document, which is not a Word document, is what is stored in Git, not the C code. That's a product of code generation that you can sort of, redo anytime. So it's a sort of product of that.
Let me briefly jump in. That we basically, call it crazy. How can you do, write requirements documents and hoping that they are consistent and then give it to we kind of laughed about this ridiculous process that we use, but it gets even in some sense worse. Both Václav and I, we've met domains where they noted that they have to become more formal. And then they hacked literally 25 pages of Boolean expressions that are supposed to be a medical treatment algorithm into Word without any tool support, without the ability to execute. This is maybe even more ridiculous, right? I mean, it's like we programming in Notepad without a compiler, but hoping to get it correct. It is crazy.
This idea of kind of manual intervention at every single turn might be good as a job preservation program.
Yeah.
Not really efficient. Let's move on. Markus, I believe you made the point with me. DSLs are about business things. Programming is about implementing those. Can you expand on that a little bit and kind of get a little specific about how you would sit down and actually do it?
Yeah, so an example from the healthcare domain. We worked with a company called Voluntis in the digital therapeutics field. So it's basically you get apps on your, where's the camera, on your phone with that guide you through some kind of treatment. For example, you might go through chemotherapy and you have to take your temperature a couple of times during the day. You have to say something about your appetite and stuff like that. So this thing basically guides you through and tells you, take this pill here, take the temperature again, please, or worst case, call your doctor. The algorithm is kind of out of ideas. So the healthcare experts, which would be the subject matter people, they describe when to ask the user what, when to recommend what, judge certain responses. If at this time of the day the temperature is above such and such with this and this history, then that's kind of alarming. Stuff like that. And so they spend weeks writing these algorithms with the DSL. They play through them. They have a simulator. They even get like a little simulator that looks like a phone, so you can actually play through the app. So that's the businessy thing, although business is the wrong word here, the subject matter, right? But then what is about software? Well, we have to run this on an iPhone. So we have to somehow get it to be able to work in the background, which kind of doesn't work on iPhones. So you have to reactivate the app from time to time. If you want to remind the user to take their temperature, you can't have a background process. You have to actually make a calendar entry so that iOS pops up a reminder. You want to be able to, if the application goes to sleep, then you have to restart it with a certain state. This is all software stuff. These people, the domain people, don't care about it. So mapping from what it is they want to do to the iOS specifics in this case, that's what the software people do. That's what programming is about.
Markus, we discussed that to get business people to use something, you have to build a notation, symbology, jargon, whatever you want to call it, that's close to what is in their domain in order to get them to really adopt. What do you mean by this?
Well, we already kind of hinted at a couple of things earlier in our conversation. Tables are really something subject matter people like. Any textbook, whatever domain, has lots of tables for those things that can be represented systematically, almost formally, like certain conditions and data in these conditions is tables. So replicating them one-to-one directly in code with all the lines and the headers and gray and bold and stuff. This is really nice. Another example, the tax law in Germany, to the degree it is systematic, it almost implies a certain tree structure. It says here's the income tax, and it's composed of dependent, like employee style income and kind of self-employed income. I don't know the English terms. So there's kind of an ontology, a hierarchy is almost implied. There's almost a tree in the text. So the language we've built uses a tree style notation so that the code you write structurally almost directly resembles what you read from the law, if you understand it correctly. Mixing that with the tables, which you sometimes can also find in the law, with direct support for notions like yearly or monthly, which you can assume is something you find a lot in tax law because you have monthly income, you have yearly tax declarations. So all of these things clearly emphasize that, or make clear that once you design the DSL well, the language is very close to the subject matter itself, both in abstraction, but also in the specific notations you choose. People told us, before we introduced the DSL, we wrote almost like design documents. In Germany, they're called Pflichtenheft, the book of responsibilities for the developer. That's literally what it's called. Now they don't
like
need
a Monty
this.
Python skit.
Yeah, kind of, right. Right. Now the code is so close to the domain that you don't need a design document.
Yeah,
it's really helpful.
Yeah, I mean, part of that is like, okay, great, it's a compact notation, but it's also kind of cognitively, you're really giving them a place to attach to grab onto. And on this point, Václav, DSLs, or maybe I should say the language workbench, I believe you stated it as having their kinds of things or a place to make their kinds of entities as first-class language constructs in their language. But as you said, with modern tooling that you get out of the box, you don't have to make it yourself. IDE support, completion, static analysis, meaningful error messages, I believe important. Was a big point. Yeah. So could you dive into a little bit about getting from talking about something to actually sitting in front of the language workbench and doing it?
Well, I'll give you an example, right? Why the tooling is so important, right? So when, for example, when you have a physicist, who wants to manipulate, some physical simulation. So they want to have objects. Objects have some properties. These properties typically come with, properties like mass, velocity, rotation. And, these properties are not only some value, but they also come with physical units. And so you need to have a type system in the language that supports physical units, that gives the physicist sort of confidence that they are not adding, kilograms into where distance is expected, right? So type system is a very important part of the language, or you might call it tooling, right? But it's part of the language that helps a great deal. In DSLs that are more oriented towards the sort of economy, right? Like accounting DSL, then you might be manipulating elements like invoices, accounts, interests. Again, you might have numeric values, but here they mean typically money, so they are accompanied with currencies. And again, the type system should make sure that you're not adding not adding amounts of different currencies, together. So the type system is a very important part of surprisingly quite a large number of domain-specific languages. Then the error messages, right? The messages that tell you that something in your model is not valid. The instant feedback you get from when you interact with your model, you create something and you instantly get back some sort of warning telling you, hey, that's not right. Hey, maybe you've made a mistake here. You omitted a thing here. And you can actually do two kinds of validation here. You can either do prevention, so you can your language can be constrained to a point where the user is actually not allowed to make that kind of mistake, because the language guides the user, by what the whatever is offered, whatever is the user can actually insert from certain predefined set of options, and only the valid options are offered. So that is the rather restrictive approach. Well, the other approach is you give the user a little bit more freedom to create stuff, and then, after the code has been changed or added, then you underline or highlight the problem and somehow indicate to the user that there is a problem. And with some kind of problems, you can actually offer automatic quick fixes, so some way that the user can just press a button and the thing gets fixed.
And if I can jump in, we have built systems where we have integrated rather advanced analyses. For example, for those people who have some background in formal methods, we've integrated SMT solvers and model checkers. Model checkers are particularly interesting because they can, I use a little bit of air quotes, they can prove that, because it's not an analytical proof, it's not a symbolic proof, but still they can give you a lot of confidence, I should probably say, that for all possible executions of a program, certain dangerous states, which you have to describe what it means to be dangerous, will never be reached. And if you try to use these tools directly, you have to express your problem in a very low-level, mathematically inspired language, which basically nobody does, except if you're in a university or at Microsoft Research or at NASA, right? No, really. I mean, it's these kind of people who publish about these things. If you hide the math behind a nice-looking language, which underneath is actually a state machine, so you can do model checking, this is really beneficial, and it has nothing to do with code completion or with code generation even. So it's advanced analyses packaged in a user-friendly way. Very powerful.
Hey, let's jump right into this, maybe for both of you. What's it like for one of these people to sit in front of these tools? For example, a Herman.
Well, I mean, fundamentally, it looks like an IDE, right? It's like an IntelliJ, but with a different language, which, by the way, is a little bit of a problem, because even if you define a nice language, if you give them a complicated looking tool, they might be, demotivated, not by the language, but by the stuff around it, which is why specifically for MPS, you can customize the UI to get rid of all the buttons you don't need. But basically, it's like an IDE-ish kind of thing. And then they have editors and explorers and code completion, as Václav said. But when you press code completion, you don't get, monad, insert monad here. You get insert new insurance contract, or insert new tax rule, or insert new validation rule. So, and then they play around with these things. They might have, interpreters. They might have simulators, which they can use to play with this diagnostics algorithm I mentioned before. And then they can, for example, from playing through one of these healthcare treatment algorithms, they can record this and get the stub of a test case. They add a bunch of assertions, and they have a test they can regression execute on the build server. So the overall workflow is very much inspired by how software people work. You specify, you play with it, you write tests, you commit, you automatically run regression tests, but it's all with languages and abstractions and notations that are subject matter specific.
That's kind of interesting, because you're saying that the last part was speaking on their terms, but the first part of your sentence is there's no more impedance mismatch when they hook up with the software developers, because it's a lot of the similar kinds of things.
So this gets to a very interesting discussion. So what is the difference between software development and subject matter specifying, modeling, whatever it's called, right? We don't have a really good name for it. And in my opinion, there are quite a bit of difference. For example, the idea of coming up with your own generalizations and abstractions, that's fundamentally programming. It's not so much relevant for using a DSL. Or, for example, caring about scalability, performance, security, robustness, not something for the domain person, but very much for the software person. Thinking about complexity, dependency, modularity, cohesion, well, that is something you'll find in these domain-specific languages as well. And sometimes the subject matter people struggle with this a little bit, right? Because they now have to think about what does it mean to have a dependency on something else. There is a bit of education going on. I think this is another kind of bold claim, or maybe controversial claim. I think these kinds of things, thinking about what does it mean to be executable, what is a program versus data, what is a dependency, stuff like that, this should be in every curriculum, in every domain.
Václav, similar question for you. In your talks, you go over language workbenches as a tool for creating languages. Can you talk about how that works in real practice, maybe in a real example?
Yeah, sure. Well, when you're creating a language, well, each language has a syntax, right? That's the essential thing. Actually, there are two kinds of syntaxes for every language. There's a syntax for the computer and a syntax for the human. The syntax for the computer, it is basically the way the program represents your code in memory. So it's an abstract syntax tree is the official term for that. So it's a objects connected hierarchically in parent-child relationship. So, for example, an if statement, right? And perhaps any language needs some sort of condition. So an if statement, which has would be in that abstract syntax, would be sort of an object that has three children: one for condition, one for the positive true branch, one for the false branch, and so you have a little tree that represents if statement in the memory of a computer. For the human, the syntax for the human is essentially the notation, right, or grammar or editor. Well, there are different names for that, and that's how the code is presented on the screen to the user. So an if statement would have the if keyword, left parenthesis, then the condition, then right parenthesis, left brace. That would be in the Java-like language, right? You might have obviously different notations for the same thing. Some workbenches actually give you the option to have multiple notations, like the human readable notations for a single, the computer syntax element, right? So you have multiple notation and switch between them, just looking at the code, through different lenses, through different perspective. So, the first task when you're designing a new language is to design the syntax, but basically both syntaxes. So how the computer will look at your program and how the person will view it. So that's the first thing you have to create. Once you have that, then, you should perhaps address some constraints, because not all values should be allowed. Let's say the names that you put, like a tax rule might have a rule that the name must reflect some naming scheme, so that should be reflected in the constraints, or that some integer value must be within some range. So again, you should provide constraints for that. Type system, that's another thing that you should probably provide for many languages. As I mentioned earlier, that can be very useful to have rules that calculate types of values in a language. And obviously the generator semantics of your language is very important as well. If your language is supposed to have some sort of effect, you can run it. It should have some runnable meaning. Then you perhaps need to have to have some means to run it, either interpret it or generate it into some code that you can interpret or that you can compile and run in some way. So an essential part of this is a generator, which is essentially a model-to-model transformation engine. It takes abstract syntax tree, the syntax the syntax for the computer, and translates it into an abstract syntax tree of some other language that you perhaps have a compiler for, and you can compile. Sometimes you don't go the whole way from your domain-specific language down to some low-level runnable language, but you go in steps to sort of be able to reuse these steps for other languages, or to make the steps smaller and so easier to implement. So that would perhaps be a typical approach to create a language in a language workbench. And you have it all. Markus already mentioned that, right? You've got a set of domain-specific languages to define all these aspects. So if you create a language, if you use a language workbench to create languages, you in fact consume domain-specific languages that have been designed for this very purpose, to make it easier to create languages and the individual aspects of them.
There's one thing I briefly want to add, which is, while you do all this, all the stuff that Václav said, you talk to Herman, right? The domain guru, the domain experts, and you work on the language for an hour or maybe half a day, and then you give it to that person to try it out. So I think I really want to emphasize that it is that modern language workbenches are so productive that at least during language prototyping, you can do this almost interactively with your domain gurus. I do that all the time in workshops. I understand something, I code it up, I turn around the laptop, say, here, try to express yourself with this. This is really important. It's not
I find that really fascinating. It's like you're getting really close to the source of truth.
Yeah, absolutely. And by doing this is another one of these things. By trying to formalize the stuff people throw at you into a language, well, you find inconsistencies. You find the corner cases. You can ask, is this corner case a bug or a feature? Do you need this, or did you just build this? I mean, it's basically what software analysis has always been about. You analyze a domain. I mean, earlier there were people like software analysts, right? The name doesn't exist anymore. It's uncool. But building a language is basically a formalized analysis result, which you can then execute and express yourself with.
As a living instrument, as an executable instrument.
It's absolutely, instead of just a bunch of UML diagrams. I mean, I can go on about this forever.
UML diagrams.
Yeah.
In a similar, no, that's not it at all. We just did a episode of JetBrains Connect on Kotlin, and Kotlin DSL is really a big kind of thing for Kotlin. But this isn't that. Václav, you mentioned some experience with Groovy DSLs. Groovy DSLs really isn't this either, right?
Right. It isn't. But in fact, Groovy DSLs are very powerful, right? They are, thanks to Groovy being a dynamic language, you can create very powerful notations, but that is for different audience. Right, with internal domain-specific languages like in Groovy and Kotlin, you're reusing the parser and the tooling of the host language. So you always sort of limit it. You limit it to what the language can do, and so your notation, even though you can get very far with Groovy, I can define a domain-specific language that reads like fluent English. You can have a sentence that says "order pizza with ham and tomato and mushrooms to the JetBrains office at 5 p.m. and no parentheses, no commas in there, and it is valid Groovy code, and you can define DSL like that. So this is probably how far you can get, and that's it's all allowed thanks to the possibility to to override the method invocation and property invocation mechanism of that dynamic language. But this is definitely beyond, the normal use of internal domain-specific languages, I would say. Typically, internal domain-specific languages are used as builders to build some hierarchies, user interfaces, queries, configurations. So it's to ease life of developers. So the target audience for internal DSLs, in my opinion, is the developers, right? To make the API do certain libraries, certain functionality easier, less error-prone, and such. On the other hand, what you lack is the freedom of syntax that you get from external domain-specific languages, and by far you get worse tooling support for those, right? While with external domain-specific languages, you can customize the tooling, and you can enhance it and make it very sophisticated. With internal domain-specific languages, in this regard, you are rather limited. Which is not the problem for internal, for when the user of the internal DSL is a developer. But if it's someone who's not a developer, then it becomes a problem.
The boundaries are, of course, blurring, right? I mean, internal DSLs don't let you adjust the type system, because type system is static semantics and has nothing to do with execution. Notation depends on the language. But of course, there are now, languages which can have internal DSLs, where you can plug in compiler plugins, which can then do static translations and even potentially feed back into error messages. So as usual, things are evolving in both directions. In MPS, for example, we have a language called kernel F, which is a functional kind of programming language, which we often extend for building domain-specific languages. So it kind of almost looks like an internal DSL, but it's built with the tools of static languages. So things are blurring, but I agree. It's the same label, DSL, used for things that are so different that maybe it would be better to have two different labels, which is often the case in programming.
Yeah.
So
yeah, people say that England and America are two countries divided by the same language.
Yeah.
Yeah.
And an ocean.
All right. So last word on the discussion part. This one's for you, Markus. This topic, the word paradigm gets thrown around a lot. This is legit a paradigm change, rethinking the basics of software value, how, for whom. It's also kind of a mature field, actually, and there's more to come. Can you look ahead to what's next, both for the capabilities, but also just the storytelling?
Oh, yeah. So for the capabilities, I think, I mean, I'm not trying to plug MPS too much, but considering what MPS can do, it's probably further or more than what we usually need. So in terms of how you design languages, the capabilities of the tool you get out in the end, MPS and similar tools are good enough. What is not good enough is how this is presented to the user. First of all, you don't want, a 500 megabyte or even worse, fat client Java Swing app. You want something in the browser, right? I mean, seriously, that's especially subject matter experts who are not used. They don't have admin passwords. They sometimes can't even install this stuff, right? You need different collaborations. I sometimes joke that if people think MPS is too complicated, I introduce Git, right? And then they hate Git because it's from their perspective, accidental complexity. What they really want is Google Docs style real-time collaboration. And at some point they will notice, oh shit, I actually need a branch. And then they understand the need for it, and then the tool has to build it. Or give it.
Let the complexity emerge.
It's absolutely. And so, similar thing, you want to run some of the analyses that analyze your model for the type systems or some model checker or stuff in the cloud. This needs to be kind of service-oriented, microservice-y, Kubernetes, Docker-y thing, right? So there is a lot about how you make this language story available in terms of tooling and scalability to the user. And there are a couple of initiatives. There is WebMPS, which goes in that direction. There is an open source project called Modelix that also has, runs MPS in the cloud and gives a web front end. So the community is developing in that direction, but there is a long way to go. So from my perspective, that is the biggest thing that needs to happen kind of concretely. In terms of the storytelling, honestly, this is what I'm struggling with a lot. The community, has been trying to preach this story for a long time. And for example, the term subject matter, specifically the word, is something we have adopted quite recently as part of the process of writing a manifesto that basically tries to explain what we talked about today concisely. We used domain expert and domain knowledge before. Now, the word knowledge, some people think it's about knowledge engineering. They think about expert systems from the 90s and decide it's all dead. You use neural networks now, forget about the topic. So it's very hard to tell a story that is understandable, that reaches the right people. It's not clear whether we should try to convince the subject matter experts to want this, or whether we should convince the software developers to give this to the subject matter. It's a very tough topic, and I personally and the community, I think, is struggling with this. So anyway, that's the story.
So as a final word on that, it sounds like now is actually a great time for people to start paying attention to this.
Yeah.
There's a lot of doing. There's also a lot of kind of thinking and reflecting, right?
Yes.
All right, great. Very good discussion, really thought-provoking. I'll be interested to see some of the comments and ideas that people contribute once this video is posted. This is one of those really big topics that can unearth some folks doing some wonderful work, and maybe the two of you will start some conversations with some of the audience. Let's close out with a From the Heart segment. Václav, this story about language workbenches and putting the experts in the driver's seat, what's something that sticks out about this for you?
All right, I tell you something. When I studied at university, a long time ago, I actually avoided the classes of, theory of programming languages and compilers, because I considered them really, uninteresting and, surprisingly today, irrelevant. Because, after all, I was to become a programmer, so I thought I would always be given a programming language and, and I'll be just using it to write software. And then as the language evolves, then perhaps, I'll just learn, update my knowledge and continue using that language. Why should I bother learning how to design languages and compilers? Because I'm highly unlikely to ever need that knowledge and that skill. Well, nowadays I view this, a lot differently. Now I know that, being able to create languages and have, subject matter experts actually use them to write the business logic of applications can make life of a programmer much more, interesting and easier, and also much more efficient. The projects that leverage language engineering progress, much faster and typically result in better overall quality. So, DSLs give you the feeling that you're actually causing a bigger impact on the world, on things, how they work. So, I definitely like that feeling.
That's a wonderful way to phrase it. And I'll bet there's a whole bunch of people in the audience that just did like this, because they know they feel the same way that you are. And maybe they're looking to experience some of what you've gained in this journey that you've gone on in like the last decade. Markus, you've been giving talks on this for a while.
Yeah.
And I say talks, but also listening on your podcast over the years. What's something you'd really like our audience to remember?
What I notice is that all kinds of domains become computationalized. People might have heard about computational law, smart contracts. How do you get the actual logic of such a stupid contract into this Ethereum thing? Do you want people to program in whatever the language is? I forget it. We all heard about computational biology. The BioNTech Pfizer vaccine has been compared to software, right? In the way it kind of works in terms of the ideas behind it. And so people have to think in this way. People have to kind of intellectually, knowledge workers is one of these terms where the actual work people are doing are basically brain-based, right? And then we give them Word, Doors, Excel, and expect them to write documents, which then a programmer who doesn't really care about their subject matter, they just care about the newest framework. I mean, I'm paraphrasing only a little bit, exaggerating. I mean, this is a joke, right? We have to give these people the same tools, like mechanical engineers. They couldn't do their work without the CAD program. They can't do the construction in their brain, but we expect people to do the construction of a healthcare algorithm in Word. This is ridiculous. We have to give these people the tools so they can actually express themselves, play with the stuff, find inconsistencies, and directly contribute to software.
Both of you put a smile on my face. Those are two great statements. I'll actually tie them together. Markus, you talked about computational biochemistry or something in vaccines. You want to make an impact in the world? I'll bet those vaccine makers feel like they're making a positive impact in the world, which ties over to what Václav was saying about get into a field where you're reaching the people who will reach the people. Markus, thanks a lot for all the commentary on this. And as I said before, you've talked about this a lot. Václav has talked about this. Check our show notes for links if you want to read up more on what both Markus and Václav are talking about. That's it for today's JetBrains Connect. Markus, thank you for taking the time to drop in, helping us frame this story, especially the who and the why as much as the what. And thanks for all the work on this over the years.
Well, thank you very much for the invitation. It was a lot of fun. And thank you for covering that topic. It's maybe not the most obvious one. So thank you very much.
Well, and maybe it will become more obvious in the coming years as people see the potential impact of this. Václav, thanks for helping me on the research, the deep dive on this. Like we just said, important topic, a big topic where, at least for me, behind every door was a bigger door. And behind that was like 50 bigger doors. And so you helped me sort it all out and help to get to the essential point. Thank you.
Oh, you're welcome. And thanks a lot for having me in the show. I really enjoyed our discussion.
Thanks for watching this episode of JetBrains Connect, topics and talk from across the landscape of technology. Don't forget to leave some comments, some really good comments on this one about today's show, or really any feedback you have about JetBrains Connect. Let's hear your ideas. Want more? We got more. Click subscribe down below. See you next time.